Hello everyone, I'm Sam Otis.
I'm Grace Mattis.
I'm Michael DeJong.
I'm Justin Reed.
And we are members of the Spring 2024 capstone class in the Department of Industrial and Manufacturing Systems Engineering at Iowa State University.
This semester, we collaborated with Mightyem, a company based in Peosta, Iowa, specializing in industrial equipment such as pressure washers, generators, and air compressors.
When the parts are laser cut out of metal, it produces a burr and oxide that needs to be removed before sending the parts downstream from the post-processing area. Mightyem tasked the team with increasing capacity, reducing whip on the floor, and improving the ergonomics of this process.
The three aforementioned objectives in accordance with Mightyem's goals have been defined as follows. Firstly, we'd like to increase throughput by 70%, comparable to hiring 10 new employees. Reduce the number of nests waiting to be processed on the floor by 50%, as well as improve ergonomics by reducing REBA scores by 30%.
We conducted site visits complemented by video observations of the area to capture daily operations. During our analysis, we focused on several key metrics. We counted the inventory at different stages in the manufacturing process and found 19,000 parts in post-processing, significantly more than in downstream areas, indicating a bottleneck. We did a value-added assessment and found 42.5% of time was non-value added. Mightyem currently produces 1.44 sheets per hour, which is below our targeted efficiency. An ergonomic and safety evaluation revealed that common working postures fall into the medium and high risk categories. We developed a process flow diagram to better visualize the movement and handling of materials within the facility. Mapping operator movements revealed 250 feet of material handling traveled during a cycle. Finally, we created and updated the CAD layouts to reflect the current setup of the manufacturing process.
Our team outlined 3 key deliverables to help Mightyem reach their goals. These are recommending an automated deburring machine, recommending a new floor layout, and creating a new process flow diagram to reflect these changes.
In order to increase throughput, the team met with suppliers and gathered viable machine options and proposed the integration of the Costa MD6 to automate deburring and oxide removal to best fit Mightyem's needs.
To help with process changes, our team created a new flow diagram to give a top-down overview with a large reduction in operator actions and decision points.
The team was able to start building new layout options to meet all constraints and deliverables. Important features include space for the new machine we recommended, cantilever racks to remove whip from the floor, rolling tables to create easier fork truck access, a staging rack to store parts before they are put into the deburring machine, a new attachment for the crane for lifting heavy skeletons, a return conveyor system for the deburring machine, and a lifting device for lifting parts that weigh more than 50 pounds. We evaluated these differences until one came out on top.
Automating the manual processes of deburring and oxide removal improves REBA scores by 87%, exceeding the target of 30%.
By implementing 3 cantilever racks to store the nests, Mightyem can reduce whip on the floor by 75%, exceeding the target of 50%.
Automating the post-processing decreased the time spent manually processing parts from 14.7 minutes to 8.2 minutes, while also decreasing excess part handling time from 9.2 to 0.8 minutes, increasing throughput by 79%, exceeding the target of 70%.
The initial project cost is $412,000, plus an additional $13,000 annually in consumable costs. However, by not hiring 10 additional operators to increase capacity and cost savings from whip reduction, Mightyem saves $1.9 million over 3 years. This yields a 3-year net present value of $1.38 million with a payback period of 7.4 months.
Thank you all for watching.